So hello guys, in today's video we will be talking about the distance formula. So let's start. So our target is to find the length of the line segment given the coordinates of its endpoint. The distance formula is a useful tool in finding the distance between 2 points. That can be represented by x sub 1 y sub 1 and x sub 2 y sub 2 for the second point. So for example, in a Cartesian plane, and we are looking for the distance between these 2 points. Point A has a coordinates x sub 1 y sub 1 and point B has a coordinates of x sub 2 y sub 2. So in order for us to find the distance between A and B, we get the vertical distance of A to B, and we also get the horizontal distance of B to A, or A to B. And as you notice, we form a right triangle, and let's name that point point C, whose coordinates is actually x sub 2 and y sub 1, wherein they have the same x coordinates as C and B and has the same y coordinates with A and C. Since we have a right triangle, we can therefore use the Pythagorean theorem. So in this figure, AB is our hypotenuse, so we can get the distance of AB by applying the Pythagorean theorem. AB squared is equal to AC squared plus BC squared, or the square of the hypotenuse AB is equal to the sum of the squares of the two sides of the right triangle. And for us to get the distance between A and B, first, let's see the horizontal distance of A and B, which is represented by segment AC. So that for us to get how far they are from one another, we just have to subtract the x coordinate of C minus the x coordinate of A, that is x sub 2 minus x sub 1, and the vertical distance of B and A, which is represented by segment BC, that can be obtained by subtracting y sub 2 minus y sub 1. And if we are going to substitute this in this Pythagorean theorem, we are going to obtain AB raised to 2 is equal to x sub 2 minus x sub 1 raised to 2 plus y sub 2 minus y sub 1 raised to 2. If you get the square root of both sides, we are going to get AB, so the distance AB is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And this is what we call the distance formula. So the distance D between 2 points x sub 1 y sub 1 and x sub 2 y sub 2 is given by this formula. So let's have examples. So find the distance between the coordinate negative 2, 5 and 6, 11. So first, we have to represent our points. So say for example, our first point is the negative 2, 5 and our second point is the 6, 11. You can use any of these two as your first point and second points. It will give you the same answer. So now that we know which one is our x sub 1 y sub 1 and x sub 2 y sub 2, we plug it in the distance formula. So that will give us x sub 2, which is 6 minus negative 2, and make sure you use parentheses when you substitute a negative. So 6 minus negative 2 squared plus 11 minus 5 squared. Simplifying this term will give us 6 minus negative 2 gives us 8, and 11 minus 5 gives us 6. So square the 8 and square the 6, we are going to get the distance between these two coordinates is square root of 64 plus 36, which is equivalent to the square root of 100, which is also equal to 10. Let's have another example. Find the length of the line segment joining each of the following points. Now I have here points A and B, C, D, and then G and H. So in order for us to find the distance between A and B, we plug our coordinates to the distance formula. So we're going to have 5 minus 5, so that's x sub 2 minus x sub 1 squared plus negative 6 minus 1 squared. So do your arithmetic. We are going to obtain a 0 squared plus negative 6 minus 1 is negative 7 squared, which will give us a square root of 49. Therefore, the distance between point A and point B is 7. Next, to find the distance between C and D, we will just be applying the same method. So I hope you already have found a pattern that all you need to do is to subtract the excess. So we have 0 minus 6 and then we square it. So 0 minus 6 squared. and then 6 minus negative 2 squared, which will give us a negative 6 squared plus 8 squared. And by simplifying this expression, we are going to obtain the square root of 36 plus 64, which is equal to the square root of 100, and the square root of 100 is 10. Okay, third example. Same procedure. So that's 3 minus the negative 5 squared plus 1 minus the 4 squared. So basically, the pattern is simple. All you have to do is to subtract the x again, 3 minus negative 5, and then you squared it, and then 1 minus 4, then squared it. Add them together and then get the square root. So we're going to get GH is actually equal to the square root of 3 minus the negative 5, as I've said a while ago, squared plus 1 minus 4 raised to 2. And simplifying this 3 minus negative 5, which will give us 8. So that's 8 squared, and 1 minus 4 is negative 3, and negative 3 squared is equal to 9. So 9 plus 64 gives us the square root of 73, and don't be afraid if it's the square root of 73, because it's fine since you cannot simplify the square root of 73 anymore. Therefore, the distance between G and H is the square root of 73. So I hope you're learning. Let's have more examples using the distance formula. Now, how do we use the distance formula to classify a triangle? So say for example, triangle ABC in this figure has the following vertices located at A, located at the coordinate 4, 6, B, 6, 1, C, 1, 3. So let's identify if this triangle is either an isosceles one, an equilateral triangle, or a scalene triangle. So for us to know which triangle this given is, so let's define first what is a scalene triangle. So let's recall that scalene triangles are triangles whose wherein no sides are the same. Isosceles triangle are triangles, or is a triangle with two equal sides, and equilateral triangle, all sides are equal. So with that, we can use the distance formula and check whether there are equal sides or side measurements. Okay, so let's start by finding the distance between AB, whose coordinates are 4, 6, and 6, 1, BC, whose coordinates are 6, 1, and 1, 3, and the AC, whose coordinates are 4, 6, and 1, 3. So we will be applying the same formula. So when we substitute the formula for the first one, the distance AB is 6 minus 4 squared plus 1 minus 6 squared, which will give us 6 minus 4 is 2, squared is 4, plus 1 minus 6 is negative 5, squared is 25. So 4 plus 25 is 29. The square root of 29 is just the square root of 29. For the second one, so we will be subtracting 1 minus 6, which is negative 5. When you square it, you get a 25. 3 minus 1, it will give you 2 raised to 2. So that's 4. So 25 plus 4 is also 29. Then square root of 29 is still square root of 29. So let's see if AC will also be the same as square root of 29, because if it is also square root of 29, then this triangle is an equilateral triangle. So let's see. So here we will be subtracting the 1 minus the 4, and then we square it. So that is 1 minus 4 raised to 2, which is negative 3 squared, plus 3 minus 6, which is also a negative 3 squared. So you're going to have 9 plus 9 is equal to 18, and the square root of 18 is also the same as 3 square root of 2. So as you can see, since AB is equal to BC, then this triangle ABC is an isosceles triangle. Okay, so I hope you are learning. Let's have another example. This is solving problems involving distance formula. So it's the same thing. We will be using the same formula. So Jenny wants to install a zipline in her backyard that will start from the tree in her backyard and end in her swimming pool. Lisa wants to ensure that the zipline is safe. So she asked Jenny to attach a zipline to the edge of the pool farthest from the tree. If Jenny follows Lisa's instruction, how long is the zipline in feet? So we represent our two coordinates. We have x sub 1, y sub 1 for 6, 2, and x sub 2, y sub 2 which is 12, 6. Substituting these coordinates to the distance formula, we are going to obtain 6 minus 2 squared plus 12 minus 6 squared. Simplifying terms, 6 minus 2 is 4, squared is 16, and 12 minus 6 is 6, 6 squared is 36, 16 plus 36 is 52, and the square root of 52 can still be simplified as 2 square root of 13. If you want to recall how to do that, remember, we can actually factor 52 by 4 times 13, and square root of 4 will give you 2, and square root of 13 will still be square root of 13. So 2 square root of 13. Therefore, the zipline is 2 square root of 13, or approximately 7.21 feet. Okay, so I hope you learned something from this video on distance formula, and I'm going to see you on the next video, which will be about midpoint formula. So with that, see you next time. Peace.